Good morning, children. Today we will continue discussing about the fourth chapter, that is linear equation in two variables. So linear equation in two variables. So we are already familiar with the term called linear in the second chapter. So where we have studied about the polynomials. So we already know about the linear polynomials. So what do we mean by the term linear? That is linear polynomial. Linear polynomial means the polynomial whose degree is 1. So similar is the case of linear equations. So linear equations are actually linear polynomials. That means the polynomials whose degree is 1, and they are in two variables. Here in this chapter we are going to learn about the linear polynomials in two variables. That means it will consist, the equation consists of two variables. So the general form, so it is of the form ax plus by plus c is equals to 0, as we can see. So this is a linear polynomial because the degree is 1 and it consists of two variables, that is variable x and y, where a comma b and c are real numbers. These are all real numbers. So this is a is the coefficient of x, b is the coefficient of y, and c is the constant term. And a and b not equals to 0. Here a and b must not be equals to 0. If a and b becomes 0, what will happen? So it will not remain a linear equation in two variables, because the variables will be cancelled out and it will not be a linear equation in two variables. So therefore a and b must not be equals to 0. So example, twice x plus 7y is equals to 9. X minus 4 is equals to 8y. 9y plus 7x is equals to 0. 7r is equals to s. Here, as we can see in each case, so there are two variables and the degree is 1, so therefore it is linear. So two variables are there, x and y. So here also two variables are there, that is y and x. So again in the last one, two variables are there, that is r and s. So all of these are the examples of linear equations in two variables. Now let's move to exercise 4.1. that is the first question. It is given, the cost of a notebook is twice the cost of a pen. Write a linear equation in two variables to represent this statement. So we are asked to write a linear equation to represent this statement. So what is the statement? That the cost of a notebook is twice the cost of a pen. Now a condition is there, that is take the cost of a notebook to be rupees x and that of a pen to be rupees y. So we'll consider the cost of the notebook as x and the cost of the pen as y. So let the cost of the notebook be rupees x and the cost of the pen be rupees y. Now according to the question, it is given the cost of the notebook is twice the cost of the pen. So it is given the cost of the notebook is twice the cost of the pen. So therefore the cost of the notebook, so that is x, is equals to twice the cost of the pen. The cost of the pen is y, so therefore x equals twice y. So if twice y comes to this side, it becomes x minus twice y equals 0. So therefore x minus twice y equals 0 is the required linear equation. So this is the linear equation. So let's move to question number 2. Express the following linear equations in the form ax plus by plus c is equals to 0 and indicate the values of a, b and c in each case. That means first we must convert this to the general form, that is we have already learned about the general form, that is ax plus by plus c is equals to 0. First we must convert the given linear equations into this form, and after that we will find the value of a, b and c. So let us take the first question, that is twice x plus thrice y is equals 9.35 bar. That means 5 is repeated in this case. So this is the question, twice x plus thrice y is equals to 9.35 bar. So twice x plus thrice y, so move this to this side, then it becomes minus, so minus 9.35 bar equals 0. So this we can write like this, twice x plus thrice y plus within bracket we write this minus 9.35 bar, because since minus is there, so when we give plus, so we have to take this minus sign within a bracket, equals 0. So comparing with ax plus by plus c is equals to 0, now we can compare this with the general form, that is ax plus by plus c is equals to 0, as it is in the general form. If we compare, then we get that this will be the value of a, this will be the value of b, and this will be the value of c. So therefore a, we get a is equals to 2, b equals to 3, and c equals to minus 9.35 bar. So this is a, this is b, and this is c. So therefore it is in the general form, as we can see ax plus by plus c is equals to 0. This is a, this is b, and this is c. So let's move to the next question. It is given that x minus y by 5 minus 10 is equals to 0. So we consider the second question. So this we can rewrite like this. So x plus within bracket minus 1 by 5 and y. Since 1 by 5 we can write within the bracket and the minus sign also comes there, plus this minus 10 we can write within bracket is equals to 0. So this is in the general form, as you can see ax plus by plus c is equals to 0. Comparing with ax plus by plus c is equals to 0, we get the value of a, as we can see 1 is there, nothing is written, that means 1 is there. So therefore a is equals to 1, b is equals to minus 1 by 5, and c is equals to minus 10. So comparing this one with the general form, that is ax plus by plus c, we get a is equals to 1, b is equals to minus 1 by 5, and c is equals to minus 10. So similarly do the rest. So we'll be doing the last question, that is number 8. 5 is equals to twice x. So 5 equals twice x. So twice x minus 5, we can, if we take 5 to the other side, it becomes twice x minus 5 is equals to 0. This again we can rewrite as twice x plus 0 dot y, since we can see that the y term is not there, it is missing. So therefore we can write 0 dot y, that means it becomes 0. So twice x plus 0 dot y plus this minus 5 we can write plus within bracket minus 5 is equals to 0. Comparing with ax plus by plus c equals to 0, we get a is equals to 2. Now it becomes ax plus by plus c is equals to 0. Therefore the value of a is 2, value of b is 0, and value of c is equals to minus 5. So comparing with ax plus by plus c is equals to 0, we get a equals to 2, b equals to 0, and c is equals to minus 5. So this is the answer. Now the solution of a linear equations. So let us consider a linear equation twice x plus thrice y is equals to 12. So here if x is equals to 0, if we put x is equals to 0, this becomes 0. Then thrice y is equals to 12, which implies y equals to 3. Which implies y is equals to 4. Therefore, since thrice y is equals to 12, so therefore 3 comes down and it becomes y is equals to 4. If we take x as 1, so it becomes 2. 2 plus thrice y is equals to 12. So if 2 comes to the other side, it becomes thrice y is equals to 10. 12 minus 2 is equals to 10. Therefore y is equals to 10 by 3. If x is equals to 2, if we take x as 2, it becomes 4. 4 plus thrice y equals 12. So if 4 comes to the other side, it becomes thrice y is equals to 8, because 12 minus 4 is 8. So therefore y is equals to 8 by 3. If we take x is equals to 3, then 6 plus thrice y is equals to 12. 6 goes to the other side, it becomes thrice y is equals to 6. So therefore y is equals to 2. 3 comes down and it becomes y is equals to 2. So and it goes on in this manner. So similarly we can take x is equals to 4, x is equals to 5, and it goes on. It will not end. This process will not end. So these solutions can be represented as ordered pair. So this solution can be represented as ordered pair. That means when x is equals to 0, y is equals to 4. When x is equals to 1, y is equals to 10 by 3. When x is equals to 2, y is equals to 8 by 3. When x is equals to 3, y is equals to 2. So this we can represent as ordered pair. So this is the value of x and this is the value of y. So that is when x is equals to 0, y is equals to 4. When x is equals to 1, y is equals to 10 by 3. When x is equals to 2, y is equals to 8 by 3. When x is equals to 3, y is equals to 2, and it goes on. That is, for each value of x, we will obtain a value of y. So this process will not end. For each value of x, we will obtain one value of y. So thus, we can conclude that the linear equation in two variables has infinitely many solutions. So therefore, we can conclude that a linear equation in two variable has infinitely many solutions. That means it consists of infinite number of solutions. So that's all for today. Rest we'll discuss in the next class. Thank you.